Good morning, ladies and gentlemen. I am John Ronan Reyes from the Philippines, and I am here in front of you to present my study entitled Potential Utilization of TB, Ficus Nota as Adsorbent for Copper-Contaminated Water. As we all know, copper is an important essential trace mineral to living organisms. However, an excess of copper greater than 2 mg per liter in drinking water is significantly toxic to human beings and ecological environments. Because of the dangers posed by too much concentration of metals, like copper, to the environment, humans and other living organisms, various methods have been developed to remove heavy metals from water, such as ion exchange, reverse osmosis, nanofiltration, precipitation, and solvent extraction. However, these methods have several disadvantages, such as unpredictable metal ion removal, high reagent requirement, and generation of toxic sludge. These methods are not economically appealing due to high capital or high operational costs and the disposal of the resulting sludge. An alternative and well-established technique for removing trace amount of pollutants or to recover valuable products from aqueous effluents is known as adsorption, using plant sources because they are biodegradable, reusable, and inexpensive. One of the potential sources that can be used as adsorbent is the tibig Ficus Nota fruits. Here's an example picture of that Ficus Nota fruits. Basing from the phytochemical analysis, tibig Ficus Nota fruit is composed of compounds like tannins, starch, and other functional groups, which can be utilized to bind, sequester heavy metal ions in wastewater, specifically copper ions. In addition, there is no reported study yet on the sorption capacity of tibig Ficus Nota in copper-contaminated water. The objectives of the study were to characterize the tibig adsorbents in terms of surface morphology, determine the initial and final concentration of copper in the solution before and after sorption respectively, compute for the percentage removal of copper in the solution, as well as the uptake capacity of the tibig adsorbents in the different treatments. And lastly, identify the functional groups present in the tibig adsorbents responsible for binding with copper ions. The methodology of the study includes collection of materials, preparation of tibig adsorbents, scanning electron microscopy of tibig adsorbents, preparation of copper solution, sorption experiment, determination of adsorbed copper, FTIR analysis of tibig adsorbents, and lastly, data analysis and interpretation. In preparing the tibig adsorbents, 300 grams of tibig fruits were sun-dried and pounded into smaller pieces to increase the surface area accessible for reaction. 3 types of adsorbents were prepared out of tibig. The untreated. No chemical treatment was applied. The nitric acid treated. 100 grams of tibig fruits were treated with 0.3 molar nitric acid. And lastly, the mercerized, wherein 100 grams of tibig fruits were soaked into 18% sodium hydroxide. 5 setups were prepared for the sorption experiment. Setup A served as a blank. Setup B served as a control. Setup C, untreated tibig dispersed in copper solution. Setup D, nitric acid treated tibig dispersed in copper solution. And lastly, mercerized tibig dispersed in copper solution. 2 grams of adsorbents were dispersed in 200 ml copper solution, excluding A and B. The initial and final copper concentration were determined through AAS, as well as the SEM analysis to determine the morphological structure, and the FTIR to determine the functional groups responsible for binding with copper ions. Observed properties on the adsorbents and copper solution after sorption. For the untreated, it turned from bluish to greenish color. Some floated, few settled at the bottom. For the nitric acid treated tibig, still bluish, a lot of the adsorbents floated, few settled at the bottom. For the mercerized, from bluish to blue-green. Few floated, more settled at the bottom, and more bubbles formed on top. The change in color for the mercerized tibig indicates that a chemical reaction took place, considering also the observation on the formation of bubbles. This can be explained by the fact that sodium hydroxide destroyed the pigment of the TB. The rapid change in color indicates also the complexation of copper ions with the adsorbents. Sorption experiment revealed that the mercerized TB absorbed the greatest amount of copper ions with 96.863% removal, followed by the untreated TB with 11.69% removal, and lastly, the nitric acid treated TB with 1.69% removal. It can be seen from the SM images that the untreated TB has a more rigid and compact surface. For the nitric acid treated TB, there's a total shrinkage. For the mercerized TB, it can be noted that there's a major alteration, total shrinkage, and the surface was completely destroyed and became more porous. The mercerized TB also had the greatest uptake capacity with 172.41 mg per gram, followed by the untreated TB with 21 mg per gram, and lastly, the nitric acid treated TB with 6 mg per gram. Chemical treatments of adsorbent have been shown to have significant effect on the absorption capacity of absorbents. Improvement of the absorption capacity of TB after mercerization is due to the increased surface area as well as the increased surface roughness. Surface becomes more porous due to dissolution of impurities. FTIR results showed that there was a shift in the wave numbers for functional groups such as OH, NH, C double bond O, and CC. With the promising results obtained, TB can be utilized as an efficient and low-cost biosorbent for the absorption of copper ions in aqueous solution. Thank you, that's all.